in this video we are going to discuss about the equilibrium in physical processes. Okay, what is physical equilibrium? So the equilibrium is classified into two types, physical equilibrium and chemical equilibrium. First we will deal with the physical equilibrium. Sorry. Okay, what is physical equilibrium? Means, listen here, if there is no change in chemical state, there is no change in chemical state, chemical nature, there is no change in the nature of the substance, and if the amount of substance between the physical states are same, it is said to be physical equilibrium. You may clearly understand. Example, we are going to first discuss about solid liquid equilibrium. Listen here. Example, solid ice, when it is in equilibrium with the liquid water, see here, what will be the temperature at this stage? The temperature will be 0 degrees Celsius. Okay, so at 0 degrees Celsius and 1 atmospheric pressure, the amount of ice in a container and the amount of water present in that container, they both will be constant. They both will be constant because the amount of ice melting to form water is equal to the amount of water which is freezing to form ice. Okay, so we can say that rate of melting of ice is equal to rate of freezing of water, at the same temperature and pressure, at the same temperature and pressure. Because of this reaction taking place at the boundary of ice and water, it is the amount of water and ice present in the mixture is fixed. Okay, this equilibrium can be attained only in a closed insulated thermoflask. Okay, in open container, the equilibrium cannot be attained, and also if the container is not insulated, we cannot attain the equilibrium. Since it is insulated at 0 degrees Celsius, there will be equilibrium between solid state of water, that is ice, and liquid state of water. Okay, this is one equilibrium. Then we are going to discuss about liquid vapor equilibrium. Consider the same. Liquid water in liquid state, when it is heated to 100 degrees Celsius at 1 atmospheric pressure, it will become vapor. Gaseous state. So when it is taken in a closed container, when this equilibrium is taken in a closed container, the rate of evaporation of water, how much speed the water gets evaporated, is equal to rate of condensation of the vapors, and so the amount of water and the amount of vapor present inside the closed vessel remains constant. The amount of liquid state and the amount of gaseous state remains constant. When this happens? At 100 degrees Celsius and 1 atmospheric pressure. Okay, right. So here 0 degrees Celsius, here it is 100 degrees Celsius. Okay, right. This is the freezing point of water. We can say freezing point of ice. Freezing point of water. This is the freezing point of water or the melting point of ice, we can say. Similarly, here 100 degrees Celsius is the boiling point of water. Okay. Similarly, we can attain a third type of equilibrium, which is called as third type of physical equilibrium, which is called as solid vapor equilibrium. What is it, sir? Solid vapor equilibrium. What is the process called when a solid directly converts into vapor? Solid directly changing to vapor, it is called as, very good, sublimation. It is called as sublimation. Example, take iodine solid crystals in a container. Iodine has the property of directly converting to from solid state to vapor state. So it is also a violet colored gas. So what happens? So a violet colored gas tends to occupy the container. The intensity of the gas increases. After some time it becomes constant. What does it imply? After some time there is equilibrium between iodine solid, which I initially put in the reaction, and the iodine vapors which are formed over the entire volume. Okay, here the rate of sublimation is equal to the reverse reaction. This is said to be solid vapor equilibrium. So far we discussed about solid in liquid, liquid in vapor, and solid in vapor equilibrium. So these three physical equilibriums we have discussed now. Now we are going to discuss solid in a liquid. Consider an example, sugar in water. You know very well about the saturated solution, unsaturated solution and supersaturated solution. Okay, what is here unsaturated solution? More amount of solute can be dissolved, further more amount of solute can be dissolved. Innum potalum karayum, innum konjam adhigama potalum karayum. Saturated solution means what? The solution is saturated, that is the amount of substance that can be dissolved in a given amount of solvent is reached. That amount has been dissolved, right? If we add excess of solute to that substance, the solute will remain undissolved. It will settle down at the bottom. See, consider, take water and add sugar. After saturation, if we add sugar, it will settle at the bottom. Okay, now it is called a saturated solution. When we heat, this also will dissolve. That is called a supersaturated solution. Okay, so there are three types of solutions: saturated, unsaturated, and supersaturated. Right? Clear? Here, we are dealing with saturated solution alone. The solution here is saturated, and we have added some amount of 1 to 2 grams of extra sugar. Right? See here, when we close this container for an infinite time, the amount of solid sugar and the amount of sugar in solution and the amount of sugar in solution in solvent will not change. This does not imply that doesn't happen, nothing happens. The amount of dissolution of this sugar is equal to the amount of crystallization of the sugar from the solution side. Okay, so the amount remains constant, and this equilibrium is called solid in liquid equilibrium. Solid in liquid equilibrium. Here, rate of dissolution of sugar from solid state is equal to rate of crystallization of sugar from solution state. Okay, so there is equilibrium between sugar in solid state and also in solution state. Equilibrium between sugar in solid state and also in solution state. Clear? This equilibrium is called as solid in liquid equilibrium. Now we are going to deal with the final type of physical equilibrium, nothing but the gas in liquid. So you may have bought soda from the shop. Okay, so there they are nothing but carbon dioxide gas dissolved in water. Carbon dioxide dissolved in water. So the amount of carbon dioxide dissolved, example, consider this as soda. There will be carbon dioxide in dissolved state, solution state. Okay, I'll write it as solution, SOLN shortly. Okay, that if it is closed, here we will have some amount of gaseous molecules, carbon dioxide in gaseous state. There is equilibrium between these two, carbon dioxide in gaseous state and the carbon dioxide in solution state. Right, this equilibrium exists there in gas in liquid equilibrium. Right. So how much carbon dioxide is dissolved? It is mentioned by Henry's law. That law says that amount of substance dissolved is directly proportional to the partial pressure of the carbon dioxide here. If the partial pressure of the carbon dioxide here is high, means more amount of carbon dioxide will be dissolved. If the pressure here is low, means less carbon dioxide is present inside the solution. Okay, here the carbon dioxide that is going to the gaseous state, it is equal to the rate of carbon dioxide that is dissolving. So here rate of vaporization is equal to rate of dissolution actually. So this equilibrium is called as gas in liquid equilibrium. Hope you are all very clear with the 5 types of physical equilibrium. If you think the video is useful for you, just mention the like button, subscribe and share with your friends. Thank you.